then?
NoSQL. It sounds like the rebel of the database world, breaking free from the rigid structure of traditional SQL databases. Why the need for a different approach? Why do we need something different?
Exactly. NoSQL stands for not only SQL, and it represents a shift away from the traditional table and row structure of relational databases. NoSQL databases are designed to handle the unique challenges of big data. Flexibility, horizontal scaling, and diverse data formats. They can adapt to evolving data, expand as needed, and work with data that doesn't fit neatly into rows and columns.
So it's all about embracing the chaos, the messiness, the ever-changing nature of big data. No more trying to force it into neat little boxes.
Yeah, that's the idea.
Yeah.
And one of the key concepts in NoSQL is the lack of a fixed schema. This means the data structure can evolve over time, which is essential when you're dealing with things like online trends that are constantly changing. Plus, NoSQL databases are designed to scale horizontally, so you can easily add more servers as your data grows. It's a perfect match for the dynamic nature of big data.
So no more getting stuck in the rigid world of rows and columns.
Right.
This NoSQL is all about freedom and adaptability. But wait, there's got to be a catch, right?
Right.
Every superhero has their kryptonite. What's the trade-off here?
Well, there is a fundamental principle known as the CAP theorem, which states that any distributed database system has to make a choice. You can have 2 out of 3 desirable properties: consistency, availability, and partition tolerance.
Okay.
But you can't have all 3 at the same time.
Well, that sounds deep. Can you unpack those terms for us? I'm getting flashbacks to my college philosophy class.
Don't worry, it's not that complicated.
Okay, good.
Consistency means that all nodes in the system have the same view of the data at the same time. Availability means the system is always responsive, even if some parts are down. And partition tolerance means the system keeps working even if the network connection between nodes is disrupted. The catch is, you can't optimize for all 3 simultaneously.
So it's like a real-life dilemma. Do you prioritize consistency, availability, or resilience?
Yep.
Tough choices. Can you give us an example of how this plays out in the real world?
Think about online shopping. Would you rather have slightly outdated information about a product or have the entire website crash because it's trying to ensure perfect consistency across all servers?
Yeah, that's a good point.
That's the kind of trade-off the CAP theorem forces us to consider.
Okay, I get it. So NoSQL gives us flexibility, but we need to be strategic about which CAP properties we prioritize. Makes sense.
Yeah.
Now, I know there are different types of NoSQL databases, each with their own strengths. Could you give us a quick rundown?
Absolutely. First, we have key value stores, which are the simplest type.
Okay.
Think of it like a dictionary. You have a key and it points to a value.
Right.
These are great for speed and simplicity, perfect for things like caching frequently accessed data or storing user settings. Then we have document stores designed for handling complex nested data. Imagine storing an entire user profile with all its details in a single document. That's where document stores shine. They're great for content management systems, e-commerce platforms, anything that needs flexible data modeling.
So key value is for quick lookups, and document stores are for the messy, real-world data that doesn't fit neatly into tables. What else is there?
We also have column family stores, which are optimized for analytics and fast retrieval of specific data points.
Okay.
They're great for handling time series data like sensor readings or financial transactions because you can slice and dice the data by specific categories very efficiently. And finally, there's graph databases, which are all about mapping relationships.
Okay.
Think about social networks. Each person is a node, and their connections are edges.
Yeah.
Graph databases excel at understanding and analyzing these complex webs of relationships.
Okay, so we've gone from the vastness of big data to this flexible world of NoSQL databases. But I'm itching to see how this all comes together in a real-world scenario.